A chocolate peanut caramel bar may look like a simple layered treat. Glossy chocolate on the outside, chewy caramel in the middle, crunchy roasted peanuts throughout. But behind that satisfying bite is a highly synchronized industrial process. Each layer must be engineered separately, then combined with precision so texture, sweetness, saltiness, and structure stay perfectly balanced. From roasting raw peanuts and cooking caramel under controlled heat to tempering chocolate and enrobing thousands of bars per minute, the production line blends confectionery chemistry with high-speed automation. And today, on the How Factory, we're stepping inside large-scale candy plants to see exactly how a chocolate peanut caramel bar is made, from roasted peanuts to chocolate coating. The origins of this type of candy bar date back to the early 20th century when confectioners began layering caramel, nuts, and chocolate into handheld treats. Advances in sugar refining and milk chocolate production made it possible to combine soft and crunchy textures into one product. Over time, what began as small batch candy shop creations evolved into industrially produced bars capable of maintaining consistency across millions of units. Today's chocolate peanut caramel bar must taste identical whether it's made today or next month, and that consistency begins with raw ingredients. The process starts with peanuts. Large shipments of raw shelled peanuts arrive at the facility after harvesting and drying. Before roasting, they pass through cleaning systems that remove stones, stems, dust, and foreign material using screens, air blowers, and optical sorters. Food safety is critical, so peanuts are also inspected for defects or discoloration. Once cleaned, the peanuts move to roasting. Industrial roasters use hot air circulated at controlled temperatures, often between 300 degrees Fahrenheit and 350 degrees Fahrenheit, 150 degrees Celsius to 175 degrees Celsius. Roasting develops flavor through Maillard reactions, enhancing nuttiness and deepening color. The timing must be precise. Under-roasted peanuts lack flavor. Over-roasted peanuts become bitter. Sensors monitor temperature and airflow continuously to ensure even roasting across large batches. After roasting, the peanuts are rapidly cooled to stop the cooking process. Cooling tunnels use forced air to bring them down to safe handling temperatures. At this stage, some peanuts may be lightly salted depending on the product formulation. The roasted peanuts are then stored temporarily in controlled bins until they are incorporated into the bar assembly process. Next comes caramel production. Caramel begins with sugar, glucose syrup, milk solids, butter or vegetable fat, and sometimes condensed milk. These ingredients are combined in large, steam-jacketed kettles. The mixture is heated gradually while being stirred continuously. As temperature rises, sugars dissolve and begin to caramelize, creating flavor complexity and color development. Cooking caramel is a precise operation. The temperature determines final texture. Lower temperatures produce softer caramel. Higher temperatures create firmer, chewier results. For a chocolate peanut caramel bar, the caramel must be soft enough to bite through easily, but firm enough to hold shape during cutting and enrobing. Moisture content is carefully controlled to achieve this balance. During cooking, emulsifiers may be added to stabilize the mixture and prevent fat separation. The caramel mass thickens as water evaporates and sugars concentrate. Once the desired temperature and viscosity are reached, the caramel is discharged from the kettle and transferred to holding tanks. These tanks maintain the caramel at a temperature that keeps it fluid but stable until forming. Now the bar assembly begins. In many production lines, the base layer is a mixture of caramel and peanuts. Roasted peanuts are metered into a mixing system where warm caramel is poured over them. The ratio of peanuts to caramel must remain consistent across every batch. Automated dosing systems ensure uniform distribution, so each bite contains the same crunch and chew. The peanut caramel mixture is deposited onto moving conveyor belts lined with release paper or stainless steel surfaces. A spreading system shapes the mass into a continuous slab of uniform thickness. Rollers or leveling bars ensure even distribution across the width of the belt. Thickness control is essential, as it affects final bar weight and structural integrity. Once formed, the slab moves through a cooling tunnel. Cooling solidifies the caramel and locks the peanuts in place. Air temperature and flow are tightly regulated. Rapid cooling prevents excessive spreading, while gradual cooling prevents cracking. The slab emerges firm enough to cut cleanly but still pliable. Cutting systems divide the slab into individual bar shapes. High-speed guillotine cutters or rotary blades slice the slab lengthwise and crosswise. Precision is critical. Bars must meet strict weight and dimension specifications. Optical sensors and check weighers verify consistency, rejecting any pieces outside tolerance. With the core bars formed, attention turns to chocolate. Chocolate used for enrobing must be tempered before application. Tempering is the process of carefully heating and cooling chocolate to control cocoa butter crystallization. Proper tempering ensures the final coating is glossy, smooth, and resistant to melting at room temperature. Industrial tempering machines heat chocolate to melt all crystal forms, then cool it to encourage stable crystal formation. The chocolate is held at a precise working temperature, often around 88 degrees Fahrenheit to 90 degrees Fahrenheit, 31 degrees Celsius to 32 degrees Celsius. For milk chocolate, temperature sensors continuously monitor and adjust conditions to maintain ideal viscosity and crystal structure. The bars now enter the enrobing stage. They travel on wire mesh conveyors through a curtain of flowing tempered chocolate. The chocolate cascades over the bars, coating the top and sides completely. Beneath the belt, additional chocolate coats the bottom surface. Air knives gently blow across the bars to remove excess chocolate and create a smooth, even layer. Enrobing speed and chocolate flow must be synchronized perfectly. Too much chocolate results in heavy coatings and weight inconsistency. Too little leaves gaps or exposed caramel. Vibration tables may be used to eliminate air bubbles and ensure full coverage. After enrobing, the bars enter another cooling tunnel. This cooling stage allows the chocolate to solidify and set properly. Temperature and humidity control are crucial to prevent bloom. A white discoloration caused by improper crystal formation or fat migration. Gradual cooling ensures stable structure and long shelf life. As the bars exit the cooling tunnel, they undergo quality inspection. Cameras check for coating defects, cracks, or irregular shapes. Metal detectors scan for foreign objects. Check weighers confirm that each bar meets packaging weight requirements. Any defective bars are removed automatically from the line. The final step is packaging. Bars are transferred to high-speed wrapping machines. Individual wrappers are formed from rolls of printed film, sealed around each bar and cut to size. Heat sealing jaws create airtight seals to protect freshness. Date codes and batch numbers are printed for traceability. Wrapped bars move to cartoning systems, where they are grouped into boxes for retail distribution. Robotic palletizers stack cartons onto pallets with precision, preparing them for shipment. Throughout the packaging process, automation ensures efficiency while maintaining product integrity. Behind all visible production steps lies strict sanitation and food safety management. Equipment is cleaned regularly to prevent cross-contamination. Temperature logs are maintained, and allergen control procedures are strictly enforced, particularly because peanuts are a major allergen. Facilities follow rigorous safety standards to protect both workers and consumers. Sustainability initiatives are increasingly integrated into candy production. Heat recovery systems capture energy from cooking and cooling operations. Packaging materials are optimized to reduce waste. Byproducts from peanut processing may be repurposed, and manufacturers continuously refine processes to reduce water and energy consumption. What makes a chocolate peanut caramel bar remarkable is the balance of textures achieved through layered engineering. Crunchy roasted peanuts, chewy caramel, and smooth chocolate must coexist in precise proportions. Each layer responds differently to temperature and humidity, requiring coordinated control from start to finish. From raw peanuts and caramel kettles to slab formers, precision cutters, chocolate tempering machines, enrobers, cooling tunnels, and high-speed wrapping lines, the production of a chocolate peanut caramel bar is a synchronized system designed for flavor, structure, and consistency at massive scale. And that is how a chocolate peanut caramel bar is made. Roasted, cooked, formed, coated, cooled, and wrapped, transforming simple ingredients into a perfectly layered confection enjoyed around the world. Thanks for watching. The How Factory.